Today we are going to do an experiment to understand the refraction of light rays through the rectangular glass slab. So here is my rectangular glass slab and you can see how thick it is. So we will take this face and this face as the two interfaces where the light ray will enter and it will come out. So for this, what I'll do, I have fixed a white paper on the board and I am going to trace this. The shape of this rectangular glass slab I need to trace, which I have already done for you, and the shape is already traced. I have named it as A, B, C and D. And here I have made this ray. You must have understood that this is the incident ray. The arrow shows you. So this is a ray which is incident on this surface, an imaginary ray I have made. Now what I am going to do, after I have already traced its shape and made the incident ray, I am just going to put two pins to identify the path of this incident ray, and I am going to put this rectangular glass slab back to its place so that I can understand the refraction of light through it. You can see this blue pin and green pin. So we are going to understand the refraction of light with the help of these two faces. So the light is entering through this face and it is coming out from this face. It is emerging from this face. So let us focus on this face and try to find the image of this blue pin and the green pin. Please come to this face. Right. So you can see the image of the two pins. Okay. So what I will do, that I will use this red pin and I am going to put this red pin in such a way that it is in line with the red and the blue pin. So wait, let me just fix it properly. Yes. So can you see the blue and red pin now? No, because they are now in line with this red pin. So blue and green are not seen. And for an accuracy, I'm also putting one more pin which will help me to form a line. So now all this red, yellow, blue and green are in one line. So again we are in the top view. So you can see that I have placed the two pins, red and yellow. So now what I am going to do, I am going to remove this rectangular glass slab first, and then I will remove these two pins, and let me name this as E. Is it seen? Let me use a pen, then you will be able to see. This is E, and let me name this one as F. So these two were the positions where the blue and green pins were there, and let me remove these. And after removing these, let me take these two positions also and name them as G and H. Now what I'll do, I will join these two points to basically get my emergent ray. So, and I will join it to this interface. Okay, so here I have joined it. So now let me make one normal also. So this is my normal which I am going to make. Let me use a pen, then you will be able to see it clearly. Okay, and make a normal here also. So this also you will be able to see clearly if I use a pen. Okay, so I've made this normal. So this is my emergent ray. So let me put an arrow over here, and this is my incident ray. These two are the normals. So now let us check the angle. Okay, so the incident ray, the angle that incident ray is making here, you can see this is 50 degrees. Okay, so this is 50 degrees. Okay, and what is the case of emergent ray? Let's check this. Have we done it correctly? Oh wow, this is exactly 50. You can see this line and this line. So this is exactly 50. So this angle is also 50 degrees. So these two angles are equal. So this 50 degree is what? This is angle of incidence. So I is 50 degrees. And this 50 degrees is what? Angle of emergence. So this is also 50 degrees. So why these two are equal? Because these two are parallel faces. These two are parallel faces. Here we have taken refraction through two parallel faces. So that is why these two angles are coming equal. Angle I is equal to angle E. And now let us do the next step, where we are going to join these two lines and we will get our angle of refraction. So we will join these two lines on the opposite faces, and this is my refracted ray. Incident ray, then this becomes refracted ray. Would you like to know what is the angle? Let us measure the angle here. So this is how much? So this is around 25 degrees. This is around 25 degrees. So this is your 25 degrees angle, and similarly, since these are two parallel lines also, so this is also exactly 25 degrees. Okay, so you can understand that since the light ray entered a denser medium from air to glass, so that is why the angle of refraction was less. Concepts to be learned from this experiment are that the light ray suffers refraction at two interfaces and changes its direction. The first one is this position, where the light enters from rarer air medium to denser glass medium, hence the angle of refraction is lesser as compared to angle of incidence. Similarly, when it enters from glass to air, that is denser to rarer medium, the angle of refraction is more as compared to angle of incidence, that is the ray bends away from the normal. But if you see these two rays, this incident ray and this emergent ray, they are parallel to each other, and that is why you can visualize this with the help of this angle also, which is 50 degree and 50 degree. Why this is so? Because this is an example of equal refraction. These two faces are opposite and parallel. So that is why the ray suffers equal refraction, equal and opposite refraction at these two faces, and hence this kind of parallel emergent ray is seen. But if I produce this incident ray, then what happens? Let me produce this incident ray and show you. So here I have produced, I am making some broken lines to produce this incident ray. So this clearly shows that this extended incident ray and this emergent ray, they are parallel to each other. You can see they are parallel to each other. Okay, but it is slightly displaced. It should have moved like this, but it is slightly displaced. And this displacement, they are parallel, but it is slightly displaced. So this displacement, this is known as lateral displacement. This is called the lateral displacement, represented by D. This is your lateral displacement. Thank you.